I want to start by taking something away from you, something you love. I know that is a strange way to walk onto a stage, but stay with me, because I am going to hand you something better in its place, something true. You love Mars. Don't argue with me. You do. I loved it before you were born. When I was a boy in Brooklyn, I read the Mars novels of Edgar Rice Burroughs, and I fell for a world of dead sea bottoms and ancient canals and a dying, noble civilization clinging to the last of its water. I would go out into the street at night, and I would look up, and there it was, that little steady red spark that doesn't twinkle the way the stars do, and I would think, there, that is where they are. And I wanted to go. I have wanted to go my whole life. So understand that when I tell you what I am about to tell you, I am not telling it as a man who wants to spoil your fun. I am telling it as a man who spent 50 years finding out that almost everything I loved about Mars as a boy was a lie, a beautiful lie, and that the truth, when it finally came in, was stranger and harder and more important than the fairy tale ever was. Here is the thing about a beautiful lie. Nobody has to tell it to you. You tell it to yourself. Mars did not lie to us. We lied to ourselves about Mars, over and over, for 200 years, and every single time, physics walked into the room, quietly, and took the lie apart. And every single time, we learned something we could not have learned any other way. So that is what we are going to do tonight. We are going to take the 4 or 5 great and beautiful lies about the red planet, and we are going to demolish them one by one, from the ground up, brick by brick, and see what is actually standing there when the dust settles. And I promise you, at the end, you will not love Mars less. You will love it differently. The way you love something real instead of something you invented. Let's start with the simplest lie of all. The color. The red planet. That romantic, warm, ember-glow name. Rojo. The color of Mars. The god of war. Blood on the battlefield. It sounds alive. It sounds warm. Now here is where it gets strange, and we haven't even left the first sentence. Do you know why Mars is red? It is rust. That is not a metaphor. That is chemistry. The surface of Mars is covered in iron oxide, the same compound that eats a car left too long in the rain, the same orange-brown crust that forms on an old nail. Mars is red for exactly the reason an abandoned bicycle is red. It corroded. And think about what that actually requires. To rust iron, you need iron, which Mars has in abundance, and you need something to oxidize it. You need oxygen, delivered somehow, most likely through water broken apart by sunlight over enormous stretches of time. So the very thing you find romantic about Mars, that warm red glow, is the fingerprint of a slow chemical death. It is the color of a planet that once had water and air enough to do this, and then lost it, and left behind nothing but the oxidized skeleton of what used to be. When you look up at that steady red spark and feel warmth, you are looking at a tombstone, a beautiful one, but a tombstone. The color is not the color of life. It is the color of what happens to a world after the life-giving parts have gone. That is lie number 1, dismantled. Mars is not warm and it is not alive. Mars is rust, all the way down, and the rust is telling you a story about loss, if only you will listen to it instead of your own imagination. Now, lie number 2, and this one is my favorite, because this one is about us. This is the one where we get to look in the mirror. The canals. In 1877, an Italian astronomer named Giovanni Schiaparelli looked at Mars through his telescope and saw thin, straight, dark lines crossing the surface. He was a careful man, and he called them canali, which in Italian simply means channels or grooves. A neutral word, a word about geology. But when that word crossed the ocean into English, it became canals. And a canal, in English, is a thing that is dug by somebody, on purpose. And into that mistranslation walked a wealthy American named Percival Lowell, who built himself an observatory on a mountain in Arizona for the express purpose of studying these canals. And Lowell did not see grooves. Lowell saw engineering. He saw a global network, hundreds of them, crisscrossing the whole planet, carrying meltwater from the polar caps down to the thirsty equator. He saw a dying world, an ancient and wise civilization, running out of water on a desiccating planet, building the greatest public works project in the history of the solar system just to survive one more century. He wrote books about it, beautiful books. The public devoured them. This is where Burroughs got his Mars, and this is where I got mine. A whole generation fell in love with Lowell's canals. There was just one problem. They were not there. They were never there. And here is where it gets strange, because the physics of this lie is not the physics of Mars at all. It is the physics of the human eye and the human brain. When you push a telescope to the absolute limit of what it can resolve, when you are staring at a small, shimmering, trembling disk through miles of turbulent Earth atmosphere, your eye catches scattered dots and smudges and features right at the edge of visibility. And your brain, which is the finest pattern-completing machine in the known universe, does what it always does. It connects the dots. It draws the lines. It fills in the story. It takes a random scatter of real craters and dark patches, and it strings them together into clean, straight, purposeful lines, because your brain would rather see a canal built by engineers than a meaningless smear it cannot explain. The canals of Mars were never on Mars. The canals of Mars were in here, in the wiring behind your eyes. I have spent a good part of my life fighting this exact tendency, and I want to tell you it is not a minor thing. It is one of the central problems of being a scientist, and honestly, of being a person. We are pattern-seeking animals descended from ancestors who survived because they saw the tiger in the grass even when it was only wind. The one who saw a face in the shadows and ran, lived. The one who shrugged and said, probably nothing, sometimes got eaten. So we inherited a brain that would rather invent 100 patterns that aren't there than miss the one that is. And that instinct, which kept us alive on the savannah, is the exact instinct that put canals on Mars and put a face on Mars, too. Because yes, when we finally sent cameras, one of the Viking orbiters photographed a mesa in a region called Cydonia, and the light hit it just so, and the pixels were coarse, and there it was, a human face, a mile across, staring up at the sky. And people wrote books, again. A monument, they said. Proof of a lost civilization, they said. And I said, extraordinary claims require extraordinary evidence, and let us wait for a better photograph. And we got one, years later, sharper by 100-fold, and it was a hill. An ordinary, eroded, lumpy Martian hill. The face was in here too. Same wiring, same beautiful lie. So that is lie number 2. And notice what it costs us to give it up. It costs us the neighbors. It costs us the ancient engineers and the dying civilization and the whole romance of somebody being over there, building something, looking back at us. And I know how much that hurts, because I gave it up myself, and it hurt me. But look what we get in return. We get an honest reckoning with the most dangerous instrument in all of science, which is the human observer. Every canal we erased from Mars, we learned to distrust in ourselves. And a scientist who has learned to distrust his own eyes is worth 10 who haven't. That trade is worth it, every time. Now, you might think, fine, no engineers, no canals. But surely there was life of some simpler kind, plants, vegetation. Because for decades, astronomers watched the dark regions of Mars, and they saw them change with the seasons. In the Martian spring, a wave of darkening would spread down from the poles toward the equator, and the dark areas would deepen and grow, and then in autumn they would fade. And what does a thing that greens up in spring and fades in fall sound like to you? It sounds like a forest. It sounds like a wheat field. It sounds, unmistakably, like life waking up with the warm season, exactly the way life does here. This was taken seriously by serious people well into my own lifetime. The wave of darkening was one of the best pieces of evidence anyone had that Mars was alive. And here is where it gets strange again, because the answer turned out to be almost aggressively boring, and yet it teaches you something profound. It is dust. It is wind. Mars is a planet of colossal dust storms, storms that can swallow the entire globe, and the winds sort the surface. In some seasons, the bright, fine, reddish dust gets blown off certain regions and piles up on others, exposing the darker rock beneath, and then the winds reverse and the bright dust comes back and covers it again. The dark areas were not vegetation growing and dying. They were dust being swept off and swept back on, a planet-sized broom, driven by the seasons, with not one living cell involved. I want you to sit with how badly we wanted it to be plants, and how completely it turned out to be weather. Because that gap between what we wanted and what was true is the whole story of Mars. Every time we projected life onto that world, physics answered with wind, with dust, with rust, with chemistry. Never with a heartbeat, not once. And still we kept projecting, because we could not stand the silence. And I have to tell you, that dust taught me one of the most important lessons of my scientific life, and it had almost nothing to do with Mars. In 1971, we sent a spacecraft called Mariner 9 to orbit Mars, the first machine from Earth ever to orbit another planet at all, and when it arrived, it found the entire world hidden. A global dust storm had swallowed Mars whole, wall to wall, pole to pole, and for weeks all we could see was a blank, featureless tan ball where a planet should have been. So we waited, and we watched. And as the dust slowly settled out of the sky, we measured something that quietly rearranged how I understand worlds. We watched the upper atmosphere, thick with suspended dust, grow warmer, while the surface far below it grew colder, because the dust high up was catching the sunlight and holding it before it could ever reach the ground. A veil of fine particles, thrown high enough into the air, can reach across the face of an entire planet and pull the temperature at the surface down into the cold and the dark. Now hold that thought and come home with me to Earth. Because some years later, a few colleagues and I asked a terrible question. What would happen to our own climate if a nuclear war lofted enough smoke and soot and burning city into the high atmosphere? And the physics we had first learned from the dust storms of Mars handed us the answer, and the answer was nuclear winter, a darkened and frozen Earth shivering beneath a veil of its own making. We were attacked for saying it. It was one of the hardest and loneliest fights of my life. But we had watched it happen on another planet first. Mars showed us how a world can pull its own blinds and freeze in the dark, and that is not poetry. It is the same dust, the same physics, the same cold, and it is one more way that the dead red planet keeps trying to tell us something urgent about the living blue one, if only we will hold still long enough to listen. All right, we have cleared away the surface lies, the color, the canals, the vegetation. Now I want to take you underneath, to the physics, to the real reason Mars is the way it is, because so far I have told you what Mars is not, and any fool can tear down a fairy tale. The harder and more beautiful job is to build the true picture in its place, and to do that, we have to talk about air, because everything comes down to the air. Here is a fact that should stop you cold. If you could stand on the surface of Mars right now, without a suit, the atmospheric pressure pressing on your body would be less than 1/100th of what you feel sitting in this room. About 6/1000ths of Earth's air pressure, 6 parts in 1,000. And what little there is almost entirely carbon dioxide, unbreathable, useless to your lungs. Now let me show you what that thinness actually does, with a thought experiment you can hold in your hand. Take a glass of water, ordinary water, at a comfortable temperature. Set it down on the surface of Mars. What happens? You would expect it to freeze, because Mars is cold, and you would be right, it is cold, but watch closely, because it does something much stranger first. It boils, and it freezes. At the same time, the water at the surface starts to boil away into vapor, because the air pressure is so low that liquid water simply cannot hold itself together. It flashes into gas, and the energy that boiling steals away chills what remains until it freezes solid. Boiling and freezing in the same glass, in the same instant. That is not science fiction. That is the physics of the triple point of water, and it means something absolutely decisive. It means liquid water, the one thing every romance about Mars depends on, cannot exist, stable and open on most of the Martian surface. Not because it is too cold, not only that, because there is not enough air to hold it down. So now the real question, the physicist's question, the one you should be asking. Why? Why does Mars have so little air? Earth held onto its atmosphere. Venus held onto a crushing thick one. Why did Mars end up nearly naked? And this is where we finally get to the deep machinery, and I want to build it for you carefully, because this is the heart of the whole thing. It comes down to two numbers and one catastrophe. The first number is size. Mars is small. It is about half the diameter of Earth, and only about a tenth of the mass. And a smaller world has weaker gravity. On the surface of Mars, you would weigh a little more than a third of what you weigh here. Now, gravity is what holds an atmosphere down. The molecules of air are always jittering around with heat, always trying to fly off into space, and it is a planet's gravity that keeps grabbing them back. On a big world with strong gravity, the escape velocity, the speed you need to break free forever, is high, 11 kilometers per second here on Earth, and most air molecules simply cannot go that fast, so they stay. But on little Mars, the escape velocity is only about 5 kilometers per second, less than half. The door is only half as hard to walk out of. So right away, Mars was always going to have a harder time keeping its air. That is number one, and it is baked in. You cannot fix it. You cannot make Mars bigger. But size alone is not the catastrophe. Here is the catastrophe. Here is where it gets genuinely strange, and where a whole planet's fate turned on something happening thousands of miles underground. Deep inside Earth, there is a core of molten iron, and that iron churns and flows, and a flowing sea of molten metal generates a magnetic field. You have felt this field your whole life without knowing it. It is what swings a compass needle north. And that invisible magnetic field reaches far out into space and wraps the entire Earth in a protective shell, a magnetosphere. And that shell does something we owe our lives to. It deflects the solar wind, because the sun is not just shining on us. The sun is blowing on us. It hurls out a constant gale of charged particles, protons and electrons screaming outward at hundreds of kilometers per second, a wind of raw energy that never stops. And if that wind hits a planet's atmosphere directly, it does something brutal. It picks the atmosphere up, molecule by molecule, energizes it, and strips it away into space. It sandblasts the air right off the world. Here on Earth, our magnetic field catches that wind and turns it aside, funnels most of it around us, and the leftover that leaks through we see as the auroras, the northern lights, the solar wind dying beautifully in our upper sky. The aurora is the sound of our shield working. Mars had a shield too, once. We know this because when spacecraft mapped the Martian crust, they found ancient magnetism frozen into the oldest rocks, stripes of it, a memory of a global magnetic field that Mars had in its youth, more than 4 billion years ago, when its little iron core was still hot and churning. But Mars is small, and small things cool fast, the way a cup of coffee goes cold faster than a swimming pool. And so, early in its history, the Martian core cooled, and its churning slowed, and its magnetic dynamo sputtered and died, and the shield went down. And from that moment on, for 4 billion years, the solar wind has been doing to Mars exactly what I described, sandblasting it, picking up the atmosphere, ion by ion, and carrying it off into the dark. We have watched this happen. We sent a spacecraft called Maven specifically to measure it, and it is measuring, right now, tonight, Martian air leaking away into space, the last thin remnant of a world's atmosphere being stolen one molecule at a time by a wind that will never stop blowing. Mars is not a dead world. Mars is a world still dying, slowly, in front of our instruments. Now put those pieces together, and you see the real Mars, the true picture rising out of the demolished lies. A small world, born with weak gravity and a magnetic shield. The shield fails early, because the world is too small to keep its core hot. The solar wind moves in and begins the long theft. The atmosphere thins, and as the atmosphere thins, it can no longer trap heat, and the world cools. And as it cools and the pressure drops, the liquid water that once ran across its surface can no longer survive there, so it freezes into the ground in the poles or boils away and joins the fleeing air. And the exposed iron in the rocks, over the eons, reacts with what oxygen and water remains, and rusts, and turns the whole dying planet that mournful, beautiful red. Every lie we told about Mars was our attempt to look at that story of loss and see, instead, a story of life. But the truth is the story of loss. And the truth is more important, because the story of loss is a warning, and I will come to that. But first, I have to be honest with you and tell you the part that keeps me up at night, the part we have not solved, because a scientist who only tells you the answers and never the mysteries is not being straight with you. Here is the mystery. We have found the riverbeds. We have found them all over Mars. Ancient, dried river channels and branching tributaries, and the fan-shaped deltas that form where a river empties into a standing lake, and lakebed clays, minerals that only form in the long, patient presence of liquid water. Our rovers are driving across the floors of lakes that have been dry for 3 billion years. So we know for a fact, that early Mars was warm enough and wet enough for rivers to run and lakes to stand, open to the sky, for a long time. Long enough to carve canyons. And here is the problem. We cannot, with our best physics, easily explain how. Because there is a wrinkle, and it is a beautiful one, and it is called the faint young sun. Our sun, 4 billion years ago, was not as bright as it is today. A young star of the sun's type burns dimmer, and back when those Martian rivers were flowing, the sun was putting out perhaps 70% of the sunlight it does now, less warmth. And Mars is already much farther from the sun than we are. So the young Mars should have been colder than it is even today, a deep frozen world, and yet the geology screams that it was warm and wet, with running water for hundreds of millions of years. How? What kept it warm? Some powerful greenhouse we don't fully understand? Carbon dioxide alone does not seem to be enough to do it. Was it hydrogen? Was it methane? Was it warm only in brief, violent bursts, thawed by asteroid impacts or volcanoes and then refreezing between? We do not know. We genuinely do not know. There is a warm, wet, running water Mars written plainly into the rocks, and our physics has trouble making that Mars possible, and every honest scientist working on this will tell you the same thing. That gap between the evidence and the explanation is not a comfort to me. It is a splinter in my mind. It is exactly the kind of thing that means we are missing something real about how planets and climates and greenhouse effects actually work, and finding what we are missing might teach us something about our own climate that we badly need to know. And that brings me to Viking, and I have to tell you about Viking, because Viking is personal, and because Viking is the sharpest lesson in the whole of my scientific life about the difference between what you want to be true and what is true. In 1976, we landed 2 spacecraft on the surface of Mars, the first machines from Earth ever to touch that ground and live, and I was part of that. And we did not go just to take pictures. We went to answer the oldest question. Is there life? We carried instruments designed to scoop up the Martian soil and test it, feed it nutrients, and watch for the chemical signs of something eating, breathing, metabolizing, living. And one of those experiments gave a positive result. We dribbled a nutrient broth onto the Martian soil, and the soil breathed back. It released a puff of gas, exactly, at first, as if something in that dirt were alive and consuming the meal we had offered it. I remember what that felt like. I will not pretend to you that my heart did not leap. 50 years of loving Mars, the boy in Brooklyn and the man at the console, and here was the soil answering. But we had another instrument, one that looked for the actual molecules of life, the organic carbon that every living thing on Earth is built from, the chemistry that any life we understand has to leave behind. And that instrument found nothing, no organics, or so little that it could not tell them from contamination. A planet's soil that appeared to breathe when fed, but contained none of the molecules that breathing life is made of. And so we had to be scientists. We had to do the hardest thing a scientist ever does, which is to distrust the answer we wanted. And the sober conclusion, the one most of us came to, was that the puff of gas was not biology. It was chemistry. The Martian soil, sterilized by that ultraviolet radiation pouring down through the thin, unshielded air, had become a strange and reactive thing, full of oxidizing compounds, and when we poured our broth on it, it fizzed the way peroxide fizzes on a cut, no life required. And decades later, another lander found the culprit sitting right there in the soil, salts called perchlorates, exotic reactive chemicals laced through the Martian dirt, enough to explain the fizz, and, incidentally, toxic to human beings. The soil of Mars, the soil we dreamed of planting crops in, is salted with poison. That is the reward Viking gave us for our hope. An ambiguous puff of gas, most likely lifeless chemistry, on a planet whose very dirt would sicken us. I wanted it to be life. It probably wasn't. And I have had to carry that honestly for the rest of my career, and it made me a better scientist, and it never stopped hurting. Both of those things are true. So let us tally the real Mars, the one standing here now that the lies are cleared. A small world, half-sized, weak in gravity. Air so thin your blood would boil in it, made of a gas you cannot breathe. Cold that plunges far below the coldest night ever recorded on Earth, an average around 60 below zero, Celsius, and far colder at the poles. No magnetic shield. So the surface is bathed in cosmic radiation and solar particles that would, over time, damage every cell in your body. A ground salted with toxic perchlorates. Dust storms that can bury the entire planet and blot out the sun for weeks. And the water, what water there is, locked in ice underground and at the poles, unable to run free in the open air because there is not enough atmosphere to let it. That is Mars. That is the whole truth of it. And now I have to say the hardest thing of the night, and it is about a lie we are telling right now, in our own time, not 200 years ago. Because the new beautiful lie, the one people are selling today, is that Mars is a backup, a second Earth, a lifeboat we can sail to if we wreck the first one. And I want to be very careful and very clear here, because I have spent my life arguing that we should go to Mars, and I still believe it, with all my heart. But not for that reason, not as an escape, because the physics does not permit the escape. Think about what it would take to make Mars into a home, to terraform it, to give it a thick, warm atmosphere and running water and open sky. You would have to find enough carbon dioxide and other gases to thicken the air by 100-fold or more, and when scientists went looking, in all the accessible reservoirs, the poles, the soil, the rocks, there is not nearly enough there to do it. The gas is gone. The solar wind took most of it, 4 billion years ago, and it is not coming back. And even suppose you could somehow manufacture a thick new atmosphere by some magic we do not possess. There is still no magnetic shield. The dynamo is still dead. The same solar wind that stripped the first atmosphere would begin, patiently, to strip your new one, and you would be bailing out a boat with a hole in the bottom, forever. Mars cannot easily be a second Earth, because Mars already tried to be Earth, 4 billion years ago, and lost. What you are looking at is the wreckage of that attempt. And I want you to feel, for just a moment, what that wreckage would do to a human body, because the brochures never show you this part. The moment you step outside the shield of Earth's magnetic field and settle on a world that has none, you begin absorbing radiation, day after day, cosmic rays out of the deep galaxy and storms of particles from the sun, sleeting down through that thin, unshielded air and through the walls of any habitat we could realistically build, damaging a little more of your DNA with every week that you stay. Your bones, in that 1/3 gravity, would thin and soften the way an astronaut's do in orbit, and nobody on Earth knows the true long-term cost, because no human being has ever lived out a life at 1/3 of a gravity, and we would be finding out the hard way, with our own bodies, in real time. Your lungs would never once, not for a single breath, taste open air. Your crops would be fighting to grow in soil laced with poison. And when the great dust storm came, and it would come, it could blot out the very sun that your solar panels and your greenhouses and your life depend on for weeks across the entire planet at once. This is not a frontier like the American West, with air to breathe and water in the rivers and soil that wants to grow things for you. This is the surface of a world that is actively trying, by every means of physics available to it, to kill you. To live there at all would be the single hardest thing our species has ever attempted, a permanent, unblinking act of engineering defiance against a planet that already fought this exact fight 4 billion years ago and lost. So if Mars is not a lifeboat, why go? Why do I still want to go so badly it aches? And here is where the demolished lie gives us back something worth more than the lie ever was. We should go to Mars because Mars is the greatest natural experiment ever run on the question that matters most to us, which is, what does it take for a world to stay alive? We have 2 planets right next door that ran the experiment for us. Venus, almost exactly Earth's size, but a little closer to the sun, and something there went catastrophically wrong in the other direction. A runaway greenhouse, an atmosphere so thick and hot, the surface is a furnace that would melt lead, hot enough and crushing enough to kill you a dozen ways in a second. And Mars, a little smaller, a little farther, where the atmosphere leaked away and the world froze into rusted silence. Too hot on one side, too cold on the other. And Earth, this one particular world, threading the needle in between, holding its air, holding its water, holding its magnetic shield, holding its temperature in the narrow band where rivers run and cells divide, and eventually, someone stands on a stage and asks why. That is what Mars is really for. Mars is the control group. Mars is what Earth looks like when the shield fails and the air leaks and the water flees. And once you have seen that, really seen it, understood in your bones that a world with rivers and lakes and a blue sky and open water can become that frozen, rusted, airless graveyard, and that it is not a fable. It happened. It is right there. We have driven our robots across the dry beds of its lakes. Then you cannot look at your own thin blue sky the same way again. Our atmosphere, the whole thing, all the air that has ever filled a bird's wing or a baby's first cry or a hurricane, is a film around this planet no thicker, in proportion, than the skin on an apple. That is all that stands between us and the same silence that took Mars. And we are, right now, running our own experiment on that film, changing its chemistry faster than it has changed in millions of years. And we are doing it without a control, without a backup, without a lifeboat, because Mars is not a lifeboat and never will be. I will leave you with the mystery, because I promised I would, and because the mystery is the most alive part of all of this. For all that I have told you tonight, for all the lies we have cleared away, there is one question we cannot yet close, and it is the biggest one. We do not know if Mars was ever truly alive. We know it had the water, the warmth, the time. We know it had everything life is thought to need, back in its wet young days, at the very same time that life was getting started here on Earth, next door. Two neighboring worlds, both warm, both wet, both young, 4 billion years ago. On one of them, something stirred and grew and became forests and dinosaurs and cities and you sitting in that seat. And on the other, the water fled and the air leaked away, and we do not know, we honestly do not know, whether anything ever stirred there at all before the cold came down. And there are hints that will not quite resolve. Whiffs of methane in the Martian air that come and go and that we cannot explain. And methane can be belched out by geology, or it can be breathed out by life, and we cannot yet tell which. And beneath the frozen surface, deep down where it is warmer and where liquid water might still linger in the dark, there could be, right now, the survivors. Microbes that clung on when the surface died. 4 billion years of them, hiding underground. The last citizens of Lowell's dying world, real after all, not engineers, not canal builders, just life, holding on in the dark beneath a red and rusted sky. We do not know. We have not looked in the right place yet. We are going to. So here is what I want to leave in your chest on the drive home. You came in loving a Mars that never existed, the warm red world of canals and neighbors, and a soft second home waiting for us among the stars. I have taken all of that away from you tonight, brick by brick, and I told you I would give you something better, and here it is. The real Mars is a world that had everything, rivers, warmth, an ocean's worth of possibility, a sky, and lost it, all of it, to physics that did not care how beautiful it was. And it is sitting up there tonight, that same steady red spark I stared at as a boy, not as a promise, but as a warning, written across the whole face of a dead world, in a language of rust and thin air and fled water, that says only this: it can happen. It did happen. It is happening still, one molecule at a time, in the solar wind. Now go outside tonight and find that red spark, and look at it, and then look down at the ground under your feet, this warm, wet, breathing, shielded, impossibly lucky ground, and ask yourself the only question that matters. If it could happen to a world that had everything, what, exactly, do you think is protecting this one? Nothing you cannot break. Good night.